I've noticed that we haven't paid much attention to the brave specimen himself. This is Django. I specifically plan to mount the module on him by making a sort of a vest. You should see the vest right here. The dimensions of the vest are marked as yellow numbers. Please note that the measurements are calculated in centimeters. So, speaking about the module itself, here's what it will consist of. The ESP32, aka Node MCU. This will be the main microcontroller unit, the brains, if you will. Now, the GPS module. Here it is itself. I don't really know whether it's counterfeit or not. There's just too many of them in the market, but it turns out to do quite a good job. Oh, and also we would also try to hook up this FPV camera feed. I showcased it in the prior video, by the way, so I don't think I need to acquaint you much with this cam. Alright, before I even show how to interface this module, I would like to mention how the GPS system works. Let's start with the basics. The GPS system overlays a virtual grid on the Earth's surface. With just two coordinates, we can basically pinpoint a position anywhere on the globe. This axis of freedom are the so-called longitude and latitude, i.e., the equator and the prime meridian. Knowing this, let's now move to space. Well, alright, this should look more like space. You see here in space, a series of satellites are gloriously orbiting the Earth. These very satellites transmit exact timely synchronized signals, which the GPS module graciously receives, and based on the traveling time of these aforementioned signals, computes the distance between itself and the satellites. Concomitantly, the GPS uses this very knowledge of its position in accordance to the spacecraft and calculates its current position on Earth, i.e., the longitude and latitude. Let's now test out and see what the GPS module actually receives and computes. Here I am running the uCenter program hosted by uBlocks. Right in the centered upper right corner, a map is displayed. It in its turn gives us an accurate representation of the satellites that are hovering above us. In the far right window, we can notice that we are having a stable 2D GPS fix. This means we have pinpointed and afterwards registered from 3 to 12 satellites in the EEPROM, well, the electrically erasable programmable read-only memory. Mind you, the minimum satellites needed to get a GPS fix is 3, and the maximum is 12. On the left, however, are the NMEA lines. In short, these lines contain the various computed values, such as the GPS coordinates, i.e. the longitude and latitude, the current time of computation, the type of GPS fix, the number of registered satellites, and so on. Let's now focus on the NMEA lines. One doesn't need to be a rocket scientist to understand that each line starts with a specific character, alluding to the line stemming with the word GPGGA. This array of data contains the latitude and longitude measured in minutes and degrees. The next line contains the GPGSA values. This line contains the fixed type. Just as a side note, the longitude and latitude variables are given in degrees and minutes. That is very cumbersome, thus I convert everything into degrees. Thus, so far I assembled this very simple rig. Alright, it's night time. Thus, clear sky. Let's now set up the rig. Here, we have the PC with the sides. We have the aforementioned jerry-rigged GPS tracker. Router is here as well. Oh, what do we do now? Come on. Before I display the workings of this rig, I wish to explain what a cold boot is. You see, before any GPS gets a stable 3D or even a 2D fix, It's very necessary to allow the GPS some time to actually seek out the myriad of orbiting satellites and register them in the EEPROM. Afterwards, every boot sequence will have a shorter time period as all of the necessary satellites are already registered. Yeah, we have a full polytank here. Let me put it here. I'll put it right over here. I am located right here. As you see, slowly but surely, it's determining its position. It will get right here very soon. Just give it some time. Okay, as you can see, it's right up over here, doing its job. Right up over here. Yeah. It's positioned correctly. Either way, let us get to the practicals now. Right here, I decided to conduct a series of test trials. I'm currently located in the upper right corner of my house. This first test trial is simple and intuitive. Jog left and right and check for characteristic mismatches in my location. Mind you, this is all happening in real time. My jerry-rigged device is tracking my movement and simultaneously transmitting my coordinates to the PC all in real time. There are of course caveats to all this. For instance, sometimes the GPS just doesn't have enough satellites registered to make a fine GPS fix. At times, I'm just under a roof and thus I'm blocked from normal and good reception. Seldomly, even a simple thick cloud can determine whether my position is accurately pinpointed or strays away as the wind goes. Either way, all these issues can be easily negated by simply buying a way more expensive GPS. Just as a side note, I specifically extend my arm here in order to get the best GPS reception. Moving to the next test. Here I brought in my roots and jog all over the surroundings. Mind you, in addition to the previously mentioned caveats associated with the poor GPS reception, new ones arise. To mention, the transmission from my handheld rig to my PC is mainly based via the Wi-Fi link. Evidently, the Wi-Fi protocol works using a 2.4 GHz link, which, to be honest, does a very bad job in penetrating objects. In my case, concrete walls. Thus, whenever I stray too far from the router, I am persuaded to go back into its vicinity, because from the PC screen it becomes very evident that my pinpointed position has either stopped moving or just wanders away. Another recurring conundrum I witnessed is the latency of the whole rig. Most evidently, this arises again mostly due to the latency of the Wi-Fi link. Valuable time is also consumed by the positioning algorithm I had written. Then again, the low penetration capability of the Wi-Fi link also adds to the bandwidth crisis. Though this all seems badly change the overall tracking, this however is all negated during a fine, normal, non-cloudy day. Short disclaimer, no dogs or human beings were harmed during the experiment. The doggy most specially afterwards even got a treat. Okay, so basically this is how I mounted the whole rig. Right on the side of this little one, just look at his little eyes, is this little camera. This is how this little boy looks like. Moreover, we can also see what he's looking at right now. This is him going to my mother right now. Did you come here? Yes, keep coming. This is him walking right now. Jungle!
Снимаю.
Right now you see he's moving. Let's get a better view of it.
Мама, идеально. Мама, ну ты даешь. Идеально.
He is right now in the cage.